All right, welcome to today's lesson on application of parabolas. Now, I normally would take a screenshot of the question we're working on today, but I'm not going to do that because I'm going to read it to you, and I'm going to model annotating some of the important information. So this question is along the lines of a ball is thrown upwards, so it's thrown upwards from ground level. So it starts here and it goes up, right? It reaches a height of h meters after t seconds, all right, given by the formula. So then there's a formula and it tells me that h equals 20t minus 5t squared. Okay, so now this is where it's rather important that I've drawn these little pictures. This is h, up, we know that height is going up, and then t seconds. And what happens to time? It always keeps moving. So here's time, right? And now, hey presto, I've just suddenly drawn a little Cartesian plane. So we can think to ourselves, I'm going to be able to sketch this rule on a Cartesian plane. All right, now, looking at this rule, we should straight away notice that it has a 2 as the highest power, which means it's a parabola. We should also notice it has a negative in front of the squared, which means it's a parabola that looks like this. All right, which makes sense. If you think about throwing a ball, it doesn't do this and keep going up. It actually goes up, hits the top, and then comes back down. All right, so that makes sense in the context of the problem. Okay, in these real-world problems, you'll probably find that most of them, I won't commit to all of them, but most of them are negative parabolas because that's how real world works. It hits a top and comes back down to another side. All right, so that's the important information. I've got a pretty clear idea in my head of what's happening. I'm throwing a ball from somewhere here, it's going up and coming back down. This is the rule that tells me how high it gets to, and I'm measuring time in seconds. Okay, so A says to sketch a graph of the rule for, and it's got these funny symbols here, which I read as t is between 0 and 4, which tells me that I'm going no further than 4 seconds on my x-axis. All right, so it says sketch the graph for this t values by finding the intercepts and the coordinates of the turning point. So I need to find this point here, and this point here. So we already know that I can't sketch a quadratic without those pieces of information. So what we're going to have to do is find them. So the first step, I'm going to take my rule and I'm going to say that to find the y-intercept, I need to set x equal to 0, don't I? All right, so if I go, so y equals 20 times 0 minus 5 times 0 squared, so then y must equal 0. So there's my first point. It is at 0, 0, so I can label it on here. All right, and if you go back to the question, it actually said a ball is thrown upwards from ground level. So we could have actually confirmed that from there because ground level is a height of 0, which is what this y value is telling us. All right, so the next thing is to find the x-intercepts if we can. We remember that we have to find the x-intercept by setting y equal to 0 and then factorizing. All right, so 0 equals, now there's a t here, there's also a common factor of 5, so I'm going to divide everything by 5t, that's going to be 4 minus t. Then I'm going to say, well, if that equals 0, then t must equal 0. And if that equals 0, then t must equal 4. Which, now you know what the problem's looking like, you can see that that's clearly the end point of the graph they want you to graph. So I've got another x-intercept here. So x-intercept, x and y-intercept. Now I know that the x-intercept is midway between the two, sorry, the axis of symmetry is midway between the two x-intercepts. So the axis of symmetry is at 2. Put a dotted line here. To find out the height, all I have to do is substitute 2 into the place of t. So 20 times 2 minus 5 times 2 squared equals y. That's 40 minus 5 times 4 equals y, and 40 minus 20 is 20. So the turning point is up here at a height of 20. So the original question had said to sketch the graph. So now I've got my 3 points. I have an x and y intercept, another x-intercept, and the turning point. So now I can just join them up with as smooth a curve as possible. All right. Now, normally we would keep going into infinity. However, you can see that in this problem, that section there and that section there don't actually make any sense because this y-axis here is measuring height. If I am having a negative y value, which means a negative height, what does that mean? Does that mean the ball is below ground level or in the ground? All right, so we have to think about this in the terms of what the problem is telling us. Okay, so that's the first part. It says sketch by finding the x-intercepts, which we did here, and the turning point, which we did here. All right, so we've got the sketch. Then B says, what maximum height does the ball reach? So we could have done that by knowing what we're looking at or by looking at the graph. And you can see here the height, the highest point on the graph is clearly a height of 20. So we should say that the max equals 20 meters. Then it says, the next question is, how long does it take the ball to return to ground level? All right, so we have to remember here that the x-axis is measuring time, which answers the question of how long. So it starts here at time equals 0 and goes up. By the time t equals 2 seconds, it's at the top, comes back down and it hits the ground here where time equals 4. So in all, its flight is 4 seconds long. All right, so this application problem has taken something we already know, which is a parabola, and put it into the context of real world, which is the flight path of an object. All right, and in case you didn't realize, parabolas map the flight paths of all objects when they're thrown, because gravity acts upon them and brings them back down when they hit the top of their arc. All right, so parabolas are actually really, really useful in real world problems like this. We'll try one more and then I'll let you go and practice them. So here's the next one. And it says, the path of a javelin thrown by Joe is given by the formula h equals minus 1/16 d minus 10 squared plus 9, where h is measured in meters and it's the height of the javelin above the ground and d is the distance that it has travelled. So d is also measured in meters and it's distance that way. All right, so keep in mind that we're talking about a graph that shows this distance and that distance. All right, so distance up is called height, distance along is called distance. All right, so now we should know by now that this is the turning point form of a parabola. So we can have a look at this. We know it's got a turning point at 10, 9. So we could plot that if we wanted to and say that the highest point is there. We know it's got a negative out the front, which means it's a sad face parabola like this. We know that this dilation factor has made it quite narrow. All right, so we could, if we had a regular x squared, it would look like this. This one here is actually quite narrow and it might be like that, all right, with the same intercepts. But that's just helping us understand what we're looking at. All right, so first question says, sketch the graph of the rule for 0 to d to 22 by finding the intercepts and the coordinates of the turning point. Now we already knew where the turning point was. The turning point is at 10, 9. All right, the question here asks us to do it across this or these d values. So between d is between 0 and 22. So over here I have to put 22 as my furthest point. I'll just erase this one we did here because that was a quick sketch. All right, so now let's plot the turning point. It's at 10, 9, which we'll say is there. Then we know that turning point form, to find the x-intercepts, we have to set h equal to 0. So we're going to say 0 minus 1/16 d minus 10 squared plus 9. Rearrange, I end up with minus 9 equals minus 1/16 d minus 10 squared. Divide by 1/16 and I end up with What's 9 times 16? 90, 54 is 144. Yep, 144. It's positive because that was a negative and that was a negative. So now 144 equals d minus 10 squared. Square root both sides, end up with plus or minus 12 equals d minus 10. Add the 10 to both sides, end up with 10 plus or minus 12 equals d. So these are my two x-intercepts. We can see here that there's one at 10 plus 12, which is 22, which is what they told us was the end point. There is also one at 10 minus 12, which is minus 2. Now think to ourselves, is this one going to be something that we sketch on the axes that we've drawn? Does a negative distance from where we started make sense? All right, so hopefully everyone said no, it doesn't. So that means we're not going to graph minus 2, we're only going to graph 22. Now, we need to also find the y-intercept because this x-intercept hasn't helped us sketch the left-hand arm of the parabola. We don't know if it goes over there, or over there, or over there, or over there. All right, so we need to find the y-intercept. So, fastest way to find the y-intercept is to set x equal to 0. So we've got h equals minus 1/16, 0 minus 10 squared plus 9, which equals minus 1/16, 100 plus 9, which is 100 over 16 plus 9. Oh, now they're being tested. 100 over 16 plus 9. If we convert that into 16s, we have 144 over 16. I knew that because I did it over here. So I have 44 over 16, which I know is roughly 16, 32, 48. So it's about 2.8. Probably a bit less actually. All right, so the y-intercept is around 2.8, so we can put a quick sketch of it just here. Don't forget that without a scale, you can call the height whatever you wanted. All right, it just makes sure that when you look at your parabola, you remember it's not to scale. All right, so now I've got 3 points. I've got the y-intercept, the turning point, and the x-intercept because the other x-intercept wasn't useful in this context. So now I can sketch in my parabola like so. And we've got the path of the javelin. Now think to ourselves, why would it start at 2.8 meters above the ground? And hopefully you're familiar with how to throw a javelin, and you know that by now the person is actually holding the javelin and it doesn't start from ground level. So because the person is above the ground, it can't start at ground level. All right, so there's the quick sketch, or not the quick sketch, the sketch of the graph. You can see how we've used all the same skills that we've learned previously to find the information needed to sketch. Nothing has changed apart from that we don't call x and y anymore. What we've done is we've defined our variables. All right, we've defined our variables, and this is important because it allows you to put your answers into the context of the problem. So if someone asked you, where is the y-intercept for this javelin, you would answer, it starts at 2.8 meters above the ground. We know that because the height is 2.8 meters and not y is 2.8 meters. All right. So that's question 1. It said to sketch. Question B says, what is the maximum height the javelin reaches? So again, looking at our graph, we can see the highest point is here. It occurs after 10 meters and it is a height of 9 meters above the ground. So you would say max is 9 meters. All right. Then question C, what horizontal distance does the javelin travel? So again, we're looking at this horizontal distance here. We can see it goes from 0 out to 22. So we could say that the horizontal is 22 meters. All right. Without the defining of the variables, an answer for that question, I would expect to see people making the mistake of writing the horizontal is 22. All right. If you write down just the number, that tells me that you haven't defined your variables properly, because in the context of the problem, we know that the x-axis is measuring meters. So when it talks about using that value, you have to follow it with the label that we defined it with. All right, so a couple of things to remember there. There's no new skills in this set. The only idea is that you have to define x and y as another letter that relates directly to the problem. Other than that, when you sketch, when you solve, when you read values off the graph, you're doing the same thing as you were previously.